Welcome everyone to today's Innovation Coffee. Today we got a special episode called Simplifying IoT with Microsoft Azure. And I'm Alessandro and I'm joined by Robert as usual. Hi, Robert.
Hey, Alessandro, how's it going? I'm very excited for this episode as well. Looks like fun.
Cool. And yeah, we got a special guest, right, from Microsoft Azure. So we'll bring him in a second. As usual, Robert, why don't you do a recap of last week's episode?
Absolutely. Very fun episode last week as well. Hopefully you were able to join us. If not, of course, we save all of these live streams on the ARM Software Developers YouTube channel, the one you're watching this on right now. But last week we spoke with several folks from NGD Systems, which is a computational storage company. We were joined by some of the top tier folks there, the CTO, Vladimir. We were joined by one of the VPs of marketing, Scott Shadley. And we were joined by one of their engineers, Hermes. And we got to see some cool stuff. I mean, I didn't know so much about computational storage. And by the end of that show, I felt like I had a good grasp over it. And then Hermes, of course, provided a really awesome demo towards the end. We did go slightly over our hour mark, but I think it was definitely worthwhile. So if you have an hour and change to spare, cruise on over to the YouTube channel and check out last week's episode with NGD Systems. Lots of fun. So now on to today's episode, right, Alessandro? This looks like a good one. Carlo's got his popcorn ready.
Yeah, I see the audience is getting ready. So it's a good time to get started. So without further ado, I think we should bring in our guest. So Olivier, thank you for joining us. Welcome to the show.
Hey guys, how are you? Thanks for having me.
Hello.
Of course, thank you.
It's good to have you here. I usually see you on another show, so it's good to have you on this show now.
It's always about IoT though, right?
Yes. Always about IoT. So
I put my special IoT shirt for you guys.
Love that. I didn't see it earlier actually.
I was hiding it.
Pretty cool. Awesome. So you're a principal program manager at Microsoft. And as usual, we'd love to hear from you a bit of your background story, and not just what you do today, but actually how you got to this point in your career, in your life, and what brought you to IoT actually.
Yeah, interestingly, so that's an interesting way of approaching it. And when you asked me that earlier on, I was thinking about what could be the anecdotes that I can bring up, and there's two of them. So the background is I'm French, and I'm actually in the US. I've been here for 13 years. Back in France, I actually studies IT, and in engineering school down there. At some point, with my last year for the major, I had a choice between hardware, software, and there was a new major called real-time development systems, real-time systems development or something like that, right? And it was the one major, there was a combination of hardware and software. And it was like, I don't know, between, hardware, silicon stuff and so on, and software, so I'm going to do both. And so I went on to that major, became a specialist in real-time systems, where you have to understand hardware really well, and you have to know software really well as well. Became an expert in France on real-time system development, became an expert on Microsoft embedded technologies, especially Windows CE. That was the real-time operating system for Microsoft at the time. And Microsoft wanted to have some developer evangelists. And I was like, yeah, how about having fun coding, but not, to eat, but actually coding for fun. And I've been doing that ever so. Came back to the US to continue doing the Windows embedded evangelism thingy. Spent 3 years with the subsidiary called Microsoft Open Technology, and this is where I learned about open source, open standards, and it was a very interesting experience. And that was the subsidiary that basically paved the way for Microsoft to get into open source, to understand open source, how to work with communities, and also how to open source our own code. And after the 3-4 years, when Microsoft decided, okay, let's go full on with open source and allow all the teams at Microsoft to do open source, to work with open source, I was given the choice again. And that's the second moment in my career, I think, or in my life, where I had to choose. It was go back to Windows Embedded or go to Azure IoT. And I was like looking at that 5 years ago, I was like, Windows Embedded devices, cool, I love that, I know that. Azure IoT new, the cloud is coming into play. I know nothing about cloud. Let me apply my knowledge of the embedded stuff and teach these service developer guys, how a device looks like, and work on that. So that's how I became part of the Azure IoT team. And I started, as the PM for the SDKs, and now I'm looking after the developer communities. That's me.
That's a really good introduction. And actually, I'd like to kind of follow up on one of the last points that you mentioned, right? You said that your background is really in embedded systems effectively, and you didn't know anything about the cloud, right? And now you're working obviously in the cloud space. But what's interesting is I'm seeing more and more of these types of developers, right? Like developers that are typically embedded developers that are interested though in IoT and interested in perhaps even machine learning today, right? So kind of acquiring the need to acquire new skills in order to be successful in what they want to do, right? And I guess we'll talk about this I think throughout the show, but just kind of off the bat, what is your number one advice to someone that is getting into IoT from an embedded world?
Yeah. And as you were saying, we'll definitely touch on that topic more and more during that conversation. But IoT is becoming more and more complex, right? So it's no longer about just developing devices or building a solution that ingests data from somewhere. It's really about this end-to-end story. And so, yes, you can specialize and you can be a hardware guy, or you can be the firmware guy building the real-time OS and things and the drivers and things like that on that device. But at the end of the day, you need and you have to have a better understanding of what's next to it. So to test your firmware, you need to have a software that itself needs to connect to a cloud. So you need to know how you deploy an instance of a cloud service. You need to know how to send some messages or commands from the cloud to your device to test it. And so you need to have a basic understanding and knowledge. And then you'll see that your career actually is opening up, because instead of being in a silo, even if you love it very much and there is a future for you there, then you can become better in that area because you understand what's around. And so you can actually adapt to what's around or actually influence what the other teams are doing and how they're doing things. Or you can migrate. You can say, hey, I used to be, a real-time system developer, but I want to do, more public speaking, for example. Or you want to migrate to building cloud services because I think that cloud thing is interesting. And that could be your way of going there. IoT solutions are no longer about a device and a cloud service that are totally separated. IoT solutions now span from the device, the sensor, all the way up to the cloud integration into business applications with everything in between, right? You talked on your show about machine learning at the edge. So you start seeing how these worlds are fusing together, and you need to skill up on things that might not be your comfort zone today, but you can do that in the context of IoT solutions. And as a matter of fact, we're seeing that there's an explosion in that digital transformation era for IoT solutions. And now we are calling that IoT solutions. Some others are just calling that solutions, because as a matter of fact, devices are becoming pervasive in the world of IT and OT, and this is the way it's going. So skill up, learn new skills, new languages, new dev tools. If you've never touched IoT, look at it closely. If you're deep into embedded, look at what's happening in the software development, cloud development, and so on.
Yeah,
Oh,
sorry, please.
Sorry. No, I was just going to echo one thing that you said. I think what is really interesting about this space is that it's a crossover, right? It's a crossover between different worlds. Actually, now even more worlds with machine learning. And what's interesting to me is always that the crossover point is where innovation happens, right? Like, because it's not just about different topics, but it's also about different skills, right, that people bring to that space and different viewpoints, right? And I think the diversity in the way people are kind of thinking about problems brings new ways of doing things and new things to build, right? So actually, that's why I'm excited. So thank you for the answer. Robert, sorry, I interrupted you. Go ahead.
Oh, no, I also wanted to just echo everything that you just said. I mean, from the in-device all the way up into the cloud, everything in between, there's been a lot of talks about, this edge development that's happening right now. I'm also interested in hearing a little bit more about what you think, because, you know, one of my focuses is this cloud native development moving down to the edge or out to the edge, right? And we're seeing so much stuff happening there. But in essence, I still think there's a lot of work, right? You have all these cloud native developers, things that we need to run at the edge, and yet it's still not quite there. So seeing what Azure IoT is up to and hearing a little bit more about your own, I'm interested in hearing about what you have to think about this.
Totally. I think, Robert, what you bring up is interesting, but made me smile while you were saying it. And the reason why I couldn't keep my poker face was that actually it's not a new thing. I think I remember when I was evangelizing for Windows Embedded, Windows CE, and so on, we're talking about making devices smarter. Bringing intelligence at the edge was exactly what we were doing, but we didn't call it that way. I think the evolution is such that we were still trying to do the same things, but with the addition of new technologies, new hardware capabilities, and so on. You know, 5 years ago, 10 years ago, it was not possible to run very advanced algorithms on tiny devices running on batteries. The advance of cloud and the way now machine learning models, for example, can be, you know, trained and optimized in the cloud with the power of the cloud, and then, you know, componentized, minimized, optimized for hardware that has become better, but is still, you know, constrained. But now you can start running this kind of algorithms onto these devices. So it's not new in the sense that we're still trying to push software onto these devices. This is not new. What's new is the advance in hardware, the advance in the software itself as well, and the possibility of doing it now. Like now you can use, you know, a tiny device to do voice recognition. And you can start recognizing simple words. Something that looked like science fiction just a few years ago, it's now totally doable. But actually what that leads to is an additional complexity in terms of, I don't know ML, I don't know data scientist stuff, right? But still, I need to do development on my device to recognize a voice. How do I do that? And you need to have tools that will allow to put together these different technologies and make them accessible, still yet powerful. We'll talk about that as an example on the user interface development for embedded devices, for example. But I think in general, one of the dimensions that we didn't talk about in that complexity of IoT, it's not just in terms of the technology that are lined up next to each other and you know, software technologists or hardware technologists working on the projects. IoT solutions end-to-end are bringing the need to collaborate more with other types of engineers. It's no longer just the software engineer and the hardware engineer. Now you need to bring in the mechanical engineer, the chemical engineer, the data scientist in between. You need to actually have all these engineers work together on a solution. You were asking me, Alessandro, about, you know, what would be a nice project to talk about. So on Friday, I'm planning, like later this week, I'm planning to record an episode with a company called Symphony Zima AI. And what they're doing is they're actually bringing value in machine learning models for solutions in the realm of IoT. And an example we're going to highlight during that show is an example of a glass manufacturing furnace that needs to be monitored. And engineers knowing that type of furnaces, they know exactly how you need to manage with the temperature, depending on conditions, the type of glass you're working on. Software engineer has no idea what that means. Machine learning engineers or data scientist engineers have no idea how that works. They know their realm. Software engineers know their realm as well. But how do you make a device that will control the temperature of the furnace based on these algorithms that these specific type of engineers, you know, will define? So you need to put the glue in between all of that. You need to make it easier for these various types of engineers to work together to build solutions that are really transforming how we make business, how we manufacture stuff, and so on.
So I love how articulate you are. I'll tell you that. I mean, you are really good at explaining things. I'm really enjoying this.
I have three kids. That's why.
And you probably explain things really well to them. So that's awesome. I mean, to this point, I have a friend who brought this up to me. He was like, we've reached a time that no one person can really build anything on their own, right? Like you could even take something as simple as a pencil or even the eraser top of a pencil. And no one person can really build anything anymore, even something as simple as a pencil to something as complex as the machinery that, melts and builds out these glass things that you're talking about. So, I mean, I think it's very interesting, and I think it's pretty cool. So if you're,
I think one reaction, one remark, Robert, I think it's not that no one can build everything on their own. I think it's a matter of we don't have the time to, because if you're curious enough, you can actually, software is software, right? It's all the way down to assembly on the hardware. If you need to create software as a very reach, like all the layers in between what's happening down there and a machine learning algorithm training, all of that is understandable by someone, right? They need to learn, but you don't have time. You only have one life, and so things are becoming so advanced that yes, you need to rely on others and what they create for you to add value and to focus on an area that you're interested in and good at. And so it's more a matter of you don't have time.
Yeah.
I would like to bring another, kind of another point here. What's interesting is, in this world, in this complex world, there's more and more open source, right? Yesterday, I did another live stream, and actually we talked about open source. And what was interesting was, the concept of through open source, not only you can obviously share what you're doing, but you can also learn from others, right? Because you see all these people building cool stuff, and you can learn, right? So I think we're at a point where the complexity is so big that you can't do everything yourself, but you can work with others in different ways, obviously. And open source is one way, but it's super cool that in the open source world you can get to see and experience and collaborate with others. And in some cases, it's just about it's like it's one press of a button away, right? Like you can ask a question or participate in a group chat or whatever, and you can talk about a specific topic that you might not be very familiar with and learn about it, right? So it's super cool. I think we're at an interesting point.
What I find interesting before we jump into the actual set of demos that we have here, because I think we're running out of time, but it's so interesting, is that I believe that the value that we are all adding, is what is actually gold these days, right? As engineers, we're adding value on top of what someone else has done. So the IP no longer is solely and only in the piece of software that is now available as open source. More and more companies are just realizing that their value is not in that piece of software, is not in the IP there. The value is in the people, in the developers. They're actually making something out of it. They're building that solution. And I think this is even more exciting for developers to become, skilled in the IoT space and more generally in building solutions, technical solutions, that there is a need for them, for their creativity, for their ability to develop applications based on open source software, based on other things and the work of others. I think it's even more important, to get skilled, to learn more. It's super exciting. I think there's no better time to be a software developer or to be a how to call that? I don't know. We need to find a new term. It's not IoT developers, not software developers, tech guy. I don't know.
I mean, maybe people in the audience can tell us.
Just want to add here a pretty nice comment from Carlo agreeing with you, Olivier, scarcity of time and stuff like that. So good point. Yep.
So how about we go into some of these demos, right? I can't, because I'm talking, but eventually we can show, right?
I was gonna say, we talked a lot about, basically we didn't really give a name or label to it, but we talked about a lot of complexity and a lot of, the reason why we have you here and the reason why I'm excited to see what you're going to show us now is that Microsoft is doing a lot of great work into taking away the complexity by kind of building some plumbing, right? That others can kind of leverage. So I wanted you to kind of talk about that a little bit and then get into the demos as well. We've got a couple of really cool things that I'm excited about.
Yeah, totally. And so I think to put some frame around all of that. So we talked about the fact that IoT solutions are complex. And that's for various tons of reasons. And there's a need for simplifying how engineers collaborate, how developers work, and how they can spend time adding value. And I have some examples. I think this is one of the things that we're trying to do within the Microsoft Azure team and Microsoft in general. Is we've been known for Visual Studio, which is a great developer tool for any kind of developers. And in the same vein, with the same envy to simplify developers' life and engineers' life. With Azure IoT, we're bringing several technologies all the way from sensors, real-time operating system called Azure RTOS, Azure Sphere, Windows IoT for bigger devices, IoT Edge technology that allows you to run more of that cloud intelligence at the edge, close to where the data is generated. Cloud gateway called IoT Hub that allows you to manage these devices at scale. IoT Central, which is a more advanced, more rich solution for building your OT solutions, and then the integration into all the realm of possibilities of Azure for storage, for machine learning, for all of that, and all of that accrues to building solutions in various ways. It's one thing that I want to highlight today. This is the continuity across all the pattern, all the, how do you call that in English? I'm trying to find my words here. All the panorama of things out there, so device all the way up to cloud. But there's also various technology that you can actually double click on, and there's a couple I would like to do so today, if you allow me.
Yeah,
the
absolutely.
First one is.
So let's dive into that. Yeah, sure.
Yeah, let's do that. So the first one is about what's going on the device. And one thing that's been very complicated and still is building user interfaces. I think embedded devices are becoming richer and richer. I have here, let me try and bring up that camera here. I have here an example of what a dev kit looks like today, but it's still actually illustrating that devices are not super easy to do. The image is a bit blurry. Let me fix that live real quick. Let me put the autofocus back on. Maybe that's going to help us. Right, so you have this kind of dev kits, and then you have different formats, different form factors. You have tinier ones with smaller screens, touch screen, no touch screen, buttons, no buttons, and so on. And so at the end of the day, it's just something that is not practical developing a UI for different types of devices with all the sensors added and so on. And so the other thing is, because the devices are so much different in terms of sizes, in terms of form factors, in terms of what sensors and technology they have in there, that actually it can become really fast a nightmare. So building a display driver, for example, can be something that you need to understand, frame buffers and how to draw a pixel and blah, blah, blah. So not trivial at all, for sure. So I did write a little blog post about Azure RTOS GUIX. So shameless plug here, you can go to olivierbloch.com to read this one. I just created a new blog. That's the first big blog that I have in there. And in that article, what I'm doing is actually I'm explaining how you can leverage Azure RTOS GUIX, which is one of the libraries available in the Azure RTOS real-time OS and sets of libraries, to allow you to rapidly build user interfaces. I'm going to show you some of the tools and what it takes. But in a nutshell here, that project was about reviving. I had a little Azure Sphere device and had this flip dot panel. There's a Polish company building them, little dots that actually flip when you change the current there. And it's very low power consumption, because actually it just stays in that state until you send it a new set of data for it to change the pixels. And the idea here was to say, I want to build a UI for that. And the first instinct was to say, I'm going to build my frame buffer. I'm going to decide that a font is that many pixels horizontally and vertically, and that each letter is that memory buffer or variable, whatever constant that I'm using, and just send that manually. And then I was like, yes, but no, it's not practical. What I need is eventually to have more advanced way of doing that. And that's exactly what Azure RTOS GUIX is doing. It's bringing all the libraries, all the layers, for you to have to focus only on how is my UI going to look like, not on how I'm drawing a line, or how I'm drawing a dot, or how I'm changing a color. It has to be about how the user is going to use that thing. And came the question of, okay, so you have this rich library for building these applications and these user interfaces. But now, how do you connect to the hardware? I just mentioned the fact that hardware, is so diverse in that realm that it can become hard. And the magic of GUIX is that it interfaces with hardware in a very flexible way. If you have a very specific hardware to deliver a set of functions into a driver, that can be limited to just one function. And that's the case in that example that I developed there. Let me actually bring up the code for that guy. So I have a GitHub repo with all the code up there that shows all of that. But in a nutshell, when you look at a ThreadX application, like, it's very simple. It has a main function. It has, not this one here. It has a main function that basically is initializing the kernel. And then it will, on the ThreadX core, it will invoke the application define, which is an initialization of the application. And just to illustrate how simple it is to use GUIX and the drivers, what I'm doing in there is actually just creating that GUIX thread, and that's it. And that's GUIX thread basically, is super straightforward. It initializes the display using GUIX functions. And it will invoke the one function that the driver is exposing. And that driver, I wrote it, is like very few lines of code. And then it will create the widgets, the user interface. And I'll show some examples of very rich user interfaces in a second. But look at what my display driver looks like. This is what it is. It uses the by default available libraries in GUIX for all the work. I want to create a circle somewhere. I want to create a gradient into a piece of something there. I want to create a notion of windows or different layers. Everything is in GUIX libraries. And in my driver itself, if you look at the setup function, what it does, it initializes the hardware, and which is basically a serial port to control that little flip dot thing, and I need to create, a set of frames, and then I'm calling one generic function again to initialize the lower layer of the GUIX libraries. And this one is just to indicate, hey, we're going to use a driver that's going to be monochrome, and I'm going to just give you one function, which is the one that consists in taking the memory buffer that GUIX has for representing the pixels on the table in memory. And then I'm going to just have this one function that I'm going to actually expose, and that GUIX will invoke each time there's a screen refresh needed. And it's called the flip buffer toggle. I'm going to get the actual logical representation of my memory buffer from GUIX, and I'm going to transfer that to the hardware. This is the only function I had to develop. And this function is that big. I'm just grabbing the logical memory buffer. I'm just realigning it in the format that will be understood by the hardware. And I just send two messages over serial connection to send that to the device. So it's pretty straightforward. And you can see the device behind me. It's actually just like flipping a little dot down there. So it's very simple UI. But actually, you might want to say it's a driver. That's the side of the story here. And then you might wonder, so how did you create the UI itself, right? Because the UI itself, I was saying, can be complex. There's a GUIX Studio tool that allows you designing your UI. So the one I used was very simple. I just had a window and then a text view in there, and the text view initialized to ... and then I'm just updating that text view in order to display something new, right? And this is all there is to it. And you can see in there that I can build things more sophisticated. And here is an example of an application, which is an example of a home automation application. And here you see, well, way bigger screen, way more interaction and data in there that you can display. Actually, you would be building that WYSIWYG experience, importing the fonts, drag and dropping things and so on. But this is for an embedded device that you're building that. And GUIX abstracts the hardware. So that means that I could use that exact same UI that I'm building on different types of devices, given they have a display driver available as well as the same resolution here. And actually, let me run that real quick on that device.
Olivier, I think you stopped sharing at some point at the last minute, but when you were talking about the last application. But I wanted to while you're doing that, I wanted to pause 1 second and say, I think we lost a couple of people when where is it? There's a couple of people asking frantically about what is that flip dot. They got really excited about the flip dot.
Oh, flip dot. Yeah, so flip dot. Let me actually.
I shared it. No, I shared the link, but I think some people just already went off and started building something. I think.
Oh, my bad.
They got excited. But,
so read the blog post. Really That's what I have to say right now.
Yeah, we got some really good comments here. Pranav is saying it's really fascinating and amazing.
Yeah.
No, go on. Sorry, I stopped you. Go ahead.
No worries. And it was so much to cover. So yeah, I'm not trying to run, guys. I'm just trying to illustrate as much as possible. And here, what you can see is that UI has been developed for an embedded device. I'm here on that STMicro Discovery device, which is pretty advanced. But look at how rich a UI can be for an embedded device. And in here, everything is C code that is behind the GUIX driver, the GUIX library, right? And you can see animations, you can see gradients, transparency, all of that. There's not a single line of code that you have to write on your own to make that happen. It's something that is part of GUIX as like for free. It's part of what the library has to offer. So I really invite people to check out the blog post as an introduction to GUIX and how to build your own display driver. Because then when you see that, the problem with my flip dot panel, this little guy. Let me actually share the screen again real quick. So this guy here. This flip dot panel is a technology like you see in the airports. And at the end of the day, I was like, do I need to create my own font for that? And in GUIX Studio, I was able to just import an existing font. So I didn't even have to think about how do you build, a font. You just like import a TTF font, and you know what? Then I just put a word in my code which says like print hello world, and boom, it appears there in the right size, right format, and so on.
Olivia, I'm sure you can go so much more complex with these flip dots. It's literally just a dot matrix, right? And you could probably import real-time data following some stock ticker. You could probably tie it in with some SMS text messaging while your wife's at home. You could like text her from work and have it pop up on the flip dot. So I know this is like a hello world example, but I'm sure it can go so complex.
And once again, once you have this little guy here, it's just the beginning. Because yes, as you were saying, you're going to do something out of it. Just not flipping a dot is not enough. But here's the thing, with all that level of abstraction, with that user interface development made so much simpler, now you can start adding value. Now you can start doing things that are interesting, which is, what you just described. This is a fantastic demo on the website from that Polish company doing that device that I have on my blog post that actually shows a camera capturing people. And they're actually having a full wall of that actually whether displays the person pixelized or actually and follows the movements and so on, or actually reacts to the gestures and kind of makes some mesmerizing UI things happening on that screen. Very demo-aware, but super interesting too. So that's one way, one area where you can consider, hey, why would I need to know about how a display driver is developed? You know what? Let me go simple. Let me use a library for implementing a UI on embedded devices. And that's what we want to deliver to our customers and to our developers as Microsoft, make it simpler to implement UI on a device.
I'm laughing a little bit because while you were talking, your cat, I think, opened the door and came in the room. You had the door closed and he said...
I have not found a device to prevent him from doing that. So it's just whatever.
Love that. But no, going back to your point though, I think you raised it. We talked about a lot about complexity, and I think all these this is a good example of something that can be really simplified, right? Like you've got all this infrastructure that's there that can be utilized today, so you don't have to rebuild stuff from scratch and start from scratch and do everything yourself. So that's super interesting. And I think one of the reasons why I'm really excited to have you here is because Microsoft obviously is doing a lot on the cloud side, and there are a lot of services and a lot of things that allow that connectivity to be easier, right? Because that's a big challenge that we have in IoT, right? Is you gather data on the device and then you want to do something with it. but what is the best way to use that data, to bring that data somewhere else and to process it and so on. So I'm keen to have your view, and I know there is another demo on connectivity as well. So I'm keen to kind of have your view on maybe break down all the different services that you have in 2 minutes, or maybe give an idea of the kind of key things to look at, right? Because there's a lot of developers here that ARM developers that might not be super familiar with all the services you have, and I know you have a lot, and it can get actually quite kind of overwhelming when you look at all the different things, right? So what is the kind of 2-3 things that people should look at, and maybe we can give a couple of websites as well and put them in the description afterwards.
Yeah, and actually, that's a good segue to actually calling out an event that we have next week. Those who are following live on the 19th, we have a virtual event called All Around Azure IoT, and that's going to be basically over a day of training. We open up what are the various areas that Azure IoT is providing help for developers, tools, services, technologies, from building devices, connecting the devices securely, and then implementing IoT solutions end-to-end. And this is about Azure RTOS on the devices, Azure Sphere on the devices, the open source SDKs to connect any kind of device out there to Azure IoT. And then we talk about bringing the intelligence to the edge. This is where Azure IoT Edge comes into play. We have a runtime based on Docker that allows you to commonetize or actually export models from the cloud, that whether you build yourself or that are coming from services like storage, like cognitive services and so on. Make them containers, have them managed and deployed through the cloud gateway called Azure IoT Hub onto edge devices, and allow you to have very rich devices at the edge that were able to analyze data, take action without having to do a round trip to the cloud. So the very interesting set of technologies there at the edge that we're describing during that day of training. And then you go onto the cloud, and on the cloud itself, I just mentioned the cloud gateway IoT Hub, which is basically this kind of underlying service that serves as your entry point for devices. Securely connect, identify, recognize, and expose the data from these devices to the rest of the world. IoT Central comes on top as a layer that offers more advanced user interfaces. Think of it as a way of having an OT solution up and running in a matter of minutes. If you are fine with what 80% of the IoT solutions look like, and that's what you need, IoT Central is a great starting point, because it can be extended and offers something I'm going to show you in a minute, which is a full UI, device management out of the box, analytics out of the box, integration into business application out of the box as well, a set of APIs to work with it. It's a great tool to get started on your IoT journey. And then think about the other aspects of IoT solutions, managing data coming from different types of devices, spaces, other data sources, things that might be, blueprints from a building. When you're building a smart building solution, you need to integrate data, which is like, blueprints, for example. All of that in something that we call digital twins is made easier thanks to the Azure Digital Twins service, which think of it as a big graph for interacting with all that data coming from these things, people, spaces, offered to you, so that you can add value and integrate into your end-to-end solutions. So all that realms, I certainly don't mention all of them. So Time Series Insight is a service specialized in analyzing and storing timestamp data. It's very important for IoT scenarios, and all the other ones. So many I can hardly mention all of them.
Yeah, and we have thank you for sharing all that information, by the way. We have Peter Gallagher in the call. Going back to your cat getting in, I think that this is a good term to coin here. Cat IoT or Coyote.
IoT.
IoT focused around cats. We'll keep it at that. But he also does mention, very excited about the AAA IoT, a nice little acronym there. But he's talking about the presentations. They're going fabulously. He's going to have one, and the dry runs are going amazing. So I want to share the link one more time, and I hope that you all can go check that out. And I'm now excited about this event as well. So I think I will go check it out right after the stream. So thank you, Olivier.
Yeah. No problem. Yeah, so in that context, I mean, that gives me an opportunity to raise another problem that is actually very important. So we are seeing an evolution of the IoT space already, where just a few years, months ago, it was just about connecting a device, getting the data, doing something out of it. Now people are starting, like, it's a given, needs to happen, right? So you need to have that secure connection and so on. Now comes the second level of problem, which is, okay, I have some data coming up, but you need to decipher that data, understand that data. And as of today, there's no standard way for a device to expose its data. There's like different protocols out there. There's different options, but there's no one way. And I don't think there's going to be any of like one way anytime soon, but you need to have a set of layers, set of tools, set of services that will make it easier for a device manufacturer to present its devices to a solution developer that will integrate these devices into its solution without the need to know how to decrypt or decompose a package that is coming from a device to understand, hey, where is the temperature data? How is it looking like? Is it Celsius? Is it Fahrenheit? How many digits? What's the precision? And what are the commands that device can support? Can I tell it to shut down? Can I tell it to reset? Can I tell it to set the temperature to a certain value? These set of things that would call the interfaces or the capabilities of a device is something that is defined in different ways in different areas and realms. One thing we're trying to propose is something called IoT plug and play. The idea of IoT plug and play is to try and normalize how devices can expose their capabilities to solutions. And it starts with a description language called DTDL, which is JSON LD based. That is an open source description language that you can find on GitHub that aims at normalizing how a device can expose its capabilities. And once again, based on JSON LD, this is something that everyone should know about. And the idea there is to say a device will come online, will be able to share its capability model or to point to a registry that has all the collection of these models for a solution to just say, oh, so you're that device, so you have temperature, you have that, and you can do that command and whatnot. And so kind of automagically being able to create a UI that would be based on the capability of that device. And you can imagine now how solution can be enhanced by having new devices added without having to change a line of code in that solution. And this is today a big problem because, if you want to add some devices in a solution, it might be that you have to rewrite part of your code up there, or you have to build your own layer of abstraction. And we were saying that you can do that on your own, but do you have to? And do you want to put time and energy and money in that, or do you want to leverage something that is actually existing and that eventually we hope more and more of the industry will come around and adopt? So this is one thing I wanted to just highlight and show here with Azure IoT Central. But before jumping into the demo, do you have any questions for me, guys? I don't know. I see you're moving.
Yeah, no, I'm really excited about this because I think this is a challenge that I see a lot of partners and developers having, right? So and it's one of those things that has been looked at in different ways many times, right? And I think it's super interesting to see that you guys are doing some really good work here, and I'm excited to see more. Do we have any questions from the audience, Robert? Anything?
I don't see any questions from the audience just yet, but I'd also like to throw something out here, maybe like while you're running through this demo or explaining some of this stuff. You've thrown out, the term IoT Central, and I know I read a blog, it was a while ago now, maybe sometime last year, about the differences between IoT Central and IoT Hub. And so I'm hoping maybe, while you're going through this demo or at some point in the next few minutes, if you can maybe try to kind of like define that and give us a little bit more insight into those two aspects.
Yeah, definitely. And I can do that right now, actually.
Cool.
So IoT Hub is the cloud gateway that implements the basics of that device connectivity and communication. Establish the bidirectional communication on a safe channel with devices. So that's the underlying service that IoT Central uses to expose a higher level of functionality. IoT Central actually includes the use of various what we call PaaS services, platform as a service services. So you have IoT Hub in there, you have time series insights in there, and you have also other ones that are part of the Azure offer that IoT Central offers as a bundle, if you will, so that you don't have to compose your solution on your own. That said, IoT Central is an option. If you need to go about creating your own solution based on various services that is not the way IoT Central is bundling them, you can totally do that. You can create your own solution, aggregating the services, adding a web app on top, managing your own device management on top of IoT Hub and so on. You can do that on your own. IoT Central brings a level of abstraction that is higher than what's underneath. A good analogy for that I like to do, I don't know if everyone loves that, but I do see IoT Central as a Dynamics 365 for IoT in a way, right? Where you have something which is higher level, allows you to focus on the solution you're implementing rather than on the plumbing, which is how am I going to manage the fact there's like 200 devices, I need to send a command to each of them for updating the firmware. So you might want to have that level of granularity in control of your devices, but of your software. But eventually in IoT Central, you can use jobs that will actually automatically dispatch commands, monitor their implementation on the devices, and do real device management like that. So IoT Hub being the underlying granular service, IoT Central being the richer version that actually has user interface, user management, and all of that in there. So if you need that, use IoT Central. If you need to have the more granular level or less than what IoT Central is offering, use IoT Hub and compose your solution around IoT Hub as a service. Did that answer your question?
Absolutely, definitely explains it for me very, very well. Thank you.
Love it.
So let's see it in action then.
Let's see it in action.
Ready?
Yeah, totally. This is IoT Central. So if you want to get started, let me do that. You go to apps.azure-iotcentral.com. That's your starting point. Good news is that bad news, good news. Well, good news is you can have an Azure subscription for free to be used for deploying an IoT Central instance for free as well. There's a tier that actually allows you up to a certain number of devices, up to a certain number of messages you're going to exchange with the solution from the device that allows you to use IoT Central for free. So I really invite everyone to just go and check it out. Let me actually debunk also a not so well-known fact. People are very often, scared and concerned of creating an Azure subscription, as in, I'm going to put my credit card in there. What's going to happen? Microsoft is going to start charging me. So be reassured. Well, first you can do a trial version of Azure as a set of services. So you can create a trial and you get a voucher for a certain number of credits that you can use. But then there's a ton of resources that are available for free. If you're using low volumes and so on, you can use some services for free. IoT Central is one of them that you can use for free on Azure. And so that means that you can have an Azure subscription. Yes, you put your credit card in when you create an account on Azure and a subscription. That's because you need to have an identity, and that's the one way of verifying someone's existence and identity, using a credit card number. And so you can deploy your central application, create a new app with build, and go through a wizard that will allow you to do that. Let me switch an application already deployed, for the sake of that discussion around integrating devices into an IoT solution. So IoT Central comes with a dashboard, a way of managing devices, a way of implementing rules and deploying jobs onto devices and so on. The whole UI is all WYSIWYG. You can edit that, drag, drop things. You can create new pages. It's like pretty advanced when you think about where we're coming from in terms of building applications for IoT scenarios. There's a section there which is more about the settings. You will register what we call the device templates into a solution. You can create them manually. Say I have a device that, for example, is an IoT device. I'm going to customize that real quick. It's going to be my device type. I'm going to then, start describing what this device type is about. I'm going to create a model for that device. That model actually will have set of interfaces, set of components that describe its capabilities. If I want to add a component, a custom one, could be something that has a set of capabilities. So I need to think like register that. And I will do, for example, temperature there. And it's going to be called temp in the data. It's going to be a telemetry type of thing. And the semantic will be temperature. So I can very rapidly and comfortably create a model for my device. And then what happens is that, let me actually save that. It's a new interface. And then I can export my model, publish. And so that model is now available in my collection of devices as one of the devices models. I can create a simulator. I can now start simulating things. I didn't create any UI yet, but I could do that as well. But I want to get to my point here is that for creating that interface for that device and integrating that into my solution, even if it was easy, there was something that I had to do manually. And I had to know that the device had this kind of capabilities. I had to make sure that I was using the right name for the variable that's going to come from the device in the telemetry packet. I had to know it's a telemetry packet. There's lots of things that are happening by convention between the device manufacturer and the solution developer. Here comes IoT plug and play. So if I go back to my templates, what I could do eventually is add an existing model. So let me actually look at instead of selecting my custom one, I could actually pick one of the templates that are already available. Some of them are here and are basically an automated way of doing what I just did manually, which is creating a set of capabilities, interfaces, models, and UIs for these devices. I could just pick one of them, like for the Azure Sphere sample and so on. But then there's another more powerful way of doing that. IoT plug and play, as is described, allows for device manufacturers to expose a device model through a registry, or in the near future, directly from the device itself. Device comes online, registers to your instance of IoT Central. I didn't mention the service provision, the device provisioning service. It's one other of these services that allows acting as a concierge to allow devices securely connect to your solution. The device comes up, exposes its model identity or ID, and the solution can go grab the model from the registry. So that makes it even more dynamic and automated. So here I have several models I could pick from. I have a little wire terminal device here that I'm going to use for the demo. I could pick the model and add it to my solution so my solution would know about it. But I'm going to do something even more magical. What I'm going to do is I provision a device. Let me actually switch to the view where you will see the device itself. That's this little guy here. And this little guy actually has been provisioned to be able to connect to my instance of IoT Central. It's running a firmware that has the drivers, that basically has the IoT plug and play SDK in there. I did give it the credentials for contacting my IoT Central application. There's a scope ID, which is a unique ID for my application. There is a specific key, and then there's a device ID itself. And so device actually connected to my central application through the device provisioning service. You see, I didn't do anything. What I'm going to do now, I'm going to go back to the view of my IoT Central application. I'm going to refresh the view here. And in my list of devices, now I have a seed wire terminal appeared. It came as a device template has been downloaded. Device published, said, hey, I'm this model ID. The solution went and grabbed it from the model registry, brought it in a solution, added the device. So the device is already there. It's been provisioned in my solution. And you see here, it's already starting showing data about, the sensors immediately without me having to do anything on the solution side of things. That's what IoT plug and play is about. It's really about plug-in and playing. On the device side of thing, you need to have the bits and pieces that know how to communicate the IoT plug and play way, which is basically exposing a model ID and then sending telemetry or responding to commands. Like typically I could send some commands here, like a ring buzzer. I could do that for 2 seconds, run this thing here, and the device will start, ringing for a couple of seconds. my microphone is kind of isolating the sound there, so you should not be hearing that. But it did just ring a second or two here. So you see here, I was able to very rapidly, create an IoT solution, connect a device to the network, connect it to my IoT Central application through some provisioning, and then have this device declare its capabilities and integrate into an IoT solution that had no idea what this device was about. You can now imagine how easier it is for a developer to build a solution that will integrate future devices as well as existing ones, and for device manufacturers to be exposed more easily to a new set of customers. Because now you have a catalog of these devices that are certified for IoT plug and play, and that means that as a solution developer or builder, I can count on manufacturers to expose data from the devices in a way that I can understand. So this is one way of simplifying that integration, once again, of devices into IoT solutions that we're proposing for helping developers and making their lives simpler.
Awesome. We actually got a couple of questions. There's been a lot of chat, so I was trying to find them. I can't find them. But one question was...
Oh, sorry.
Do you have one? No, I was just going to go ahead with the simple one on the SDM. What was the device that you were using? They were asking.
Oh, yeah.
For the ST Micro Discovery Kit, the one with the UI, or the one for that
one? I think they were asking about the first one.
Yeah. So the first one is the I don't remember the exact numbers there, but that's the STM. Let's see. I think STM32F.
F7 Discovery Kit.
That's a Discovery Kit, basically. That's the one that has all the sensors, that has the display, and so on. So you can find it on ST Micro website and other places. So very useful for. I think the interesting thing with that one is you compare to other types of kits. That one has everything on it. It's not cheap, but you can definitely do lots of things in it to test your solution, to test your UI, like I was doing with GUIX there. It has networking. It has a bunch of things in there. So yeah, go check it out.
So Olivier, while digging through all the Azure IoT stuff, I noticed that you also have a Microsoft Azure certified dev kit, which is called the AZ3166. Do you happen to have one of those on your desk?
I have one somewhere.
It's okay. It's okay. I'm curious. So I have a few questions here, and then we can dive into the ones on YouTube. But so the first one is, are you aware of the process to get a Microsoft Azure certification for a hardware device? And maybe you could explain that, because I know there's lots of, ODMs, OEMs, or even just companies like 96 boards out there that their partners might be interested in possibly getting this Microsoft Azure certification so that more developers can.
Totally, actually, and I can tweet the URL once I find it and so on. But in a nutshell, here's the way it's going. So as a device manufacturer, you can apply for a certification for your device, with Microsoft. And there's different types of certification in that certified for Azure IoT. There's the basics ones, which basically certifies that your device can connect to Azure IoT. That means you need to provide a tutorial, an example of how, using one of the SDKs or using your own code, the device will securely connect to Azure IoT. And that there is a reproducible way to do that for customers to be, sure that this device will connect. Then there's another certification, which is for IoT plug and play, that comes on top of that first one. So the IoT plug and play one is about certifying your device not only can connect, but also exposes a model that is actually published in the models registry or in your own one, and that's the device complies with this model. That means that what's defining that model, I'm supporting temperature, blah, it's going to be that type of data. Then when the device connects and sends the data, we're testing during the certification process, which is all automated online, by the way. You can actually test that the device is actually sending the temperature, is actually supporting that command. So you're doing that with your real device, when you're in the process of that certification. And then you have other certification around the IoT Edge devices that are actually also in the story. But we'll find the link for you. It's pretty easy to find, actually. You can Bing that, Google that, whatever your favorite search engine. Search for Azure Certified for IoT, and you'll find the process. It's pretty straightforward to sign up as a device manufacturer on the catalog website. So then you can then publish your devices there, select what kind of certification you want to go through the process with your device, and then have someone from Microsoft also manually at some point do some tests for you and get certified.
Awesome. Yeah, no, I think that answers the question. And when we can get that link, we'll put it in the description. So Olivier, we're running short on time. I have 2 more questions here, one from YouTube and then one from me. If we can get those done really quickly, I know that your time's very valuable. So if we can just get those in here real quick.
I have time for you guys. The coffee is cold though, so we'll have to refill that.
I have an insulated mug. It's still cold. But yeah, so Tyeth in YouTube asks, so first, I'll put this up here. Peter Gallagher commented, the idea of having a library of DTDL for devices is super powerful. And then Tyeth asks here, is there any cloud platform agnostic element to the DTDL solution that you mentioned? And then, of course, this was seconded by Carlo. So
yes.
If you have something for us there.
Yes, 200%. So DTDL itself is an open source definition language. So it's a format that can be used and implemented by various services. As a matter of fact, DTDL is implemented in IoT Plug and Play and in Azure Digital Twins. As of today, only Microsoft services implement DTDL. So yes, it's kind of like all the others have it, right? But what we're trying to do here is we're trying to contribute to the community, to the effort of normalizing how these devices can declare the capabilities. So some things that we're discussing, for example, we're working with the Things Network community, which is a LoRaWAN community of developers, and we're discussing what would it make sense to use DTDL in LoRaWAN in the Things Network and the Things Stack, which is the technology that is open source and managed by the Things Network community. Would it make sense to use DTDL to describe the LoRaWAN device's capabilities? And the answer is like, maybe it would make sense. They have Cayenne, which actually is kind of a thing that tries and do that, but they're totally open to look into a JSON LD based language that they can contribute to as well, because it's open source, and adopt it. And so it was just at the beginning of that story, and here the idea is really not to impose something, but to work with the ecosystem, with the community on defining, on building what's right for building these solutions, for integrating these devices with the backend. So DTDL by nature is cloud agnostic, right? Is platform agnostic. It is there to be implemented by cloud services and by devices in that case, or by other client services.
I hope that answers your question, Tyeth and Carlo. So yeah, thank you, Olivier, for that detailed answer. The last one now that I have, and I think that this one's very important, especially considering we're on the ARM Innovation Coffee. While combing through all the documentation for Azure IoT, I came across the ARM templates. And so I'm kind of curious if you could at least what are ARM templates? Why are ARM templates important? How can developers utilize these or maximize utilizing these? In a nutshell.
Yeah, that's interesting, because the ARM template has nothing to do with ARM as an embedded technology and company. So ARM stands for Azure Resource Manager. So this is the engine that manages Azure services for you. Basically deploying a service, configuring a service, all of that go through that ARM resource management thingy. And so ARM templates are JSON files that are used to automate deployment of services configurations or compositions on Azure. So if you wanted, for example, to build an IoT solution or a solution with IoT Hub, time series insights, a website, and Azure storage, you can compose that on your Azure subscription. You can export an ARM template for someone else to redeploy that exact same setup on their own Azure subscription. So the ARM templates is really about managing your Azure resources rather than anything related to hardware.
So we got to get legal on the line. No, I'm just kidding.
Ours is an acronym.
Yeah.
I think that was interesting. Yeah, Robert. Yeah, it was interesting to bring it up, given the similarity in the acronym. but it's actually a useful thing, right? You were saying before, it actually helps if you want to build a more complex solution, right? With your device.
Yeah, it helps
one last thing.
It helps reproducing the setup. It helps eventually, sharing it. The Azure Marketplace that has solutions from our partners is actually most of the time based on ARM templates. You build a solution, you want to make it available for your customers, through the Azure Marketplace, and so customers can deploy on their own subscriptions your solution through that.
One last thing I wanted to so we're not going to really talk about this because we don't have time, but I just wanted to kind of mention it because I think it's an interesting thing, right? We talked a lot about complexity and about the fact that there's multiple kind of worlds coming together here in the IoT space, right? So I just wanted to kind of mention this. Paulo Pinto and John Moores are mentioning about higher level languages, right? And how they think Rust would be an interesting addition to C. So I think this maybe is a discussion for another time, but I think I just wanted to kind of address that, in the sense that I think I hear you guys. I think the embedded IoT community as a whole is shifting, and perhaps we'll see more of that in the future. But Olivier, thank you so much. I mean, you were an awesome guest. You actually had 2 demos. We don't get 2 demos often, so thank you.
I have more if you want.
You are so articulate, so well versed in the things you talk about. I mean, honestly, I think you make Alessandro and my job easy being hosts of this, because you're so good at what you know so much about what you're talking about, and I personally really appreciate that as a
thank you.
As a
I'm usually sitting in your seat. I'm usually the one hosting the IoT show that we have on our channels. And by the way, I need to actually invite you at some point, right? There's no reason.
Would be awesome. Yeah,
we should do that. We should do that.
We'll do that.
So maybe we'll say that next time we'll see each other on your show.
Yeah, actually, let's do that. Done. Here, live. Done.
Cool. So
cool. So
no, please. I was just gonna say thank you. I'll do it real quick. Thank you, everyone, for watching. Thank you to all the guests. Olivier, thank you so much for your time. And I mean, we went over, but much appreciated.
Yeah.
Thank you.
You want to bring back the links? So if you want to learn more about Azure IoT, we have this all around Azure AAA event coming up on the 19th, and it doesn't want to show up. Or does? Yes, it's there. And in there you're going to learn a lot about everything. There is a challenge attached to it that we invite you to go after the all around Azure event. This challenge is a 30 days to learn. You don't have to go to the AAA event. You can do that directly. Sign up for the 30 days to learn event. This challenge, this one is, if you finish that challenge in 30 days, you can get a 50% rebate on the certification for Azure IoT as a developer. So that means you can add to your LinkedIn profile that you're a certified Azure IoT developer, after you pass and successfully pass the exam. But you can get that 50% off voucher if you go to that 30 days to learn IoT thingy.
Cool. And just a bunch of things here, a bunch of thank yous to you, I guess, and given that you've done most of the presentation, so no, thank you for us as well.
And go follow Olivier on Twitter. That's it. Bloch, right?
Yep, that's me.
There you go. Awesome. Perfect.
Awesome.
Well, I mean,
thank you guys.
Thank you. It was a pleasure, and thank you to all the viewers. You've been awesome. You've been with us for 1 hour and 9 minutes and 12 seconds now. So thank you so much. See you next week.